Good morning, guys. Good morning, Samuel, Adrian, Mildred, Ferdy, Camille. Good morning. Good morning, friend. The class going to be the start right now, guys. Okay, enjoy the class and remember the process. If you had some questions, you can um, start your microphone and ask directly to the teacher, okay? Your question, he's going to respond you. The class is yours, Saad. You can
Okay.
start in the class and ask.
All right.
Thank you.
Okay. So let's start the class. All right. So okay, so today we will see exponential and logarithmic equations, like solving exponential and logarithmic equations. We will solve some of the equations, then we'll see some applications for the exponential and logarithmic equations, and then angles, their measures, and the trigonometric function for an angle. So okay, so what is an exponential and logarithmic equation? An exponential equation is an equation in which the variable appears in an exponent. So like the variable is in exponent, that's a 2 to the power x. The variable is an exponent, 2 to the power x minus 3 equals to, let's say, 5. That's an exponential equation. It includes an equation with an exponent that is the variable. Right? A logarithmic equation is an equation which includes the logarithm. Let's say log of 2x equals to, let's log 5x. Oh, it's anything. Just anything. These ones, the equations that includes the logarithms in them, they are the logarithmic equations. Okay, so to solve the exponential equations, first we see whether, okay, so whether both sides have the same number or not. Okay, so let's see here. There are some examples for the logarithmic equations. We will solve them. All right, so let's start with the first one. 3 to the power x equals to 5. Okay, so to solve a logarithmic equation, what we need to do is we can use, if we see, let's say, okay, let's start with some more basic example. Let's say we have 2 to the power 3x minus 2 equals to 4 to the power, let's say, 2x. Okay, like that. All right. So now let's try to solve it. So first of all, we will see if both the numbers, can we write them with the same base? Yes, we can write them with the same base. So we will write it as 2 to the power 3x minus 2 like this, and this thing we can write it as 2 to the power 2 into, because 4 can be written as 2 to the power 2. Then it will be 2 power 4x. So now what we do is we see that this 2 is same, this 2 is same here, and we are saying they are equal. We are saying they are equal. So if two things are equal, then this and this, that must also be equal. Okay, so it means then should also be equals to, so this thing should also be equals to that, right? Because this and this is equal, so they must also be equal. Now we just, let's say we combine the like terms. We'll subtract the 3x on both sides. So we get minus 2 equals to x. So x equals to -2. That's the solution for this one. All right. Let's see the next one. This one, 3 to the power x equals to 5. Now we don't see that both sides have the same base, so we cannot just equate the powers. So what we can do is we want to move this out of the exponent. So what we do is we take the log on both sides. We take the logarithm on both sides. So once we take the logarithm on both sides, there is a property of logarithms that tells us that the power of something, it can be written in the outside, in the start. Oh, sorry, x is the power, not the 3. So x outside and then 3. So then we can write x equals to log 5 divided by, we can use calculator. We can use calculator to get the answer in decimals, right? So let's see what's the answer for log 5 is. Answer for the log 5 is almost 0.6989, something like that, goes on. So let's put the this is the approximate sign. It does mean it doesn't mean exactly equals, but approximately equal. And log 3 is 0.4771, something like that. So just let's divide them. 0.6989 divided by 0.4771. That is 1.464, something like that. So that's the answer for the first one. Let's try the second one now. Again, what we do is we can take the log, we can take the natural log on both sides as well. Let's take the natural log for this question on both sides. ln, natural log of natural log here. So again, x minus 3 in the start and ln 6, right? Then what we do is, then we divide both sides by, and then we add the 3 on both sides. So we can like get the decimal answer by dividing ln 2 by ln 6. That is like 0.386, right? And then let's so on, and then plus 3. Okay. That's like 3.3868, something like that, or approximately. All right. Now again, let's try the third one. So now we have the exponent on both sides. We have the exponent on both sides. So we can again take the natural log, or we can take the log base 10. Anyone, it doesn't matter. Okay. Then this one in the start here, using the property of logarithms, the powers, the exponents, they came in the start. Now we see the x term is on both sides. The x term is on the left side, the x term is on the right side. So we can distribute that. So it will be 3x ln 2 minus ln 2. Here we will again distribute that, 2x ln 3 and minus 2 ln 3 natural log. Then we combine the x terms and the other terms on the other side. So, and then minus 2x ln 3 and this one on the other side, it will become 2 ln 3 plus ln 2. I moved this to the other side and I moved this to this side of the equation. Now we take the x as common from these two terms here. We get okay. Then we divide, all right? Then we divide on the other side. Then we divide on the other side. All right, either we can leave it there, or if we need a decimal answer, we can again simplify it like this. These are the powers. We can write them back into the powers. So like that. Okay, let me write it on the top corner. I'm writing now it in the top corner left here. So it will be ln 9 plus ln 2 over ln 8 minus ln 9, that's equals to x. And then again, using the property of logarithm, and the two logs are getting added, we can write them in a with the product. And when the two of them are getting subtracted, also either you can do it like this, or you can just take the values. You can just plug in the values and then get your decimal answer. Or even you can leave it there as an exact answer. It's not necessary to get decimal answers because decimal answers are not exact. The exact answers are in terms of logs. All right, so now here we have the logarithmic equations, right? We have logarithmic equation and now let's see how we can solve them, right? So on one side, you see there is a log base 4 and this and equals to 2. So like the logarithms and the exponents, they are the inverses of each other. They cancel out each other. So first of all, what we will do here is we will do is we will start by taking the exponent 4 on both, like we will write it in the exponent, like we will take the power 4 on, because the base is 4, so we will take the power 4 log 4 4. What we did, we wrote everything in the power of 4 on both sides, and there is a rule that if you have a to the power of log a and x, that's equals to x. A log a, the answer for that is they cancel out and you just get is equals to x. So 4 log 4, they will cancel out. You will get 3x minus 2 equals to 16, right? So then 3x equals to 18 and then x equals to 6. Again, let's do the next one. So in the next one, you see we have the two logs, one log here and one log equals to something. So if I take the power, it will not help. If I take the power, 3 on both sides, it will not help. Okay, why it will not help? Because if I if I wrote everything in the power here, 3 to the power this and then 3 to the power this, it will not cancel it out, because there's two different logs that are getting added. So it will not help me, it will not work. So what we do is we apply the rule of logarithms, that when the two logs are getting added and they have the same base, we can write them as one log and in the product. So I will write it like the product of, it will be x times x minus 6. I used the property of logarithm when two logs were getting added with the same base, then I wrote them with the multiplication here like this. Now what you do is, next is you take the power 3, whatever the base is, you take that power on both, like you take write this thing as an exponent of this thing on both sides in the exponent. All right, and then this one will cancel out, so it will give us x 3 to the power 3 is 27. Right, so it will be x squared 6x, and by I move this, it will become 27 on this side. Now, any of you, do you want any of you would like to tell me the factorization for this one? And if you know the factorization? How? Okay. So what we do here we have negative, we want negative 27 when we multiply them, but when we add them, we get negative 6. When we add them, we get negative 6, but when we multiply them, we get negative 27. All right. So let's see. What are the two numbers that when I add them, so like when I will add, I should get what I should get. I should get minus 6, and when I multiply them, okay, when I multiply them, I should get negative 27. So I need two numbers. So one of them can be, we can start with minus 1 times 27. When I multiply these two, I get negative 27. But their sum is not negative 6. What is their sum? Their sum is 26. Minus 1 plus 27 is 26. So it is not this pair. Again, another one that we can have is negative 27 times 1. This also gives us negative 27. But their sum is negative 26. It's not again the negative 6 that we're looking for. Okay. Next is next pair that can give us 27. Can any of you tell me the number that gives us 27 when we multiply them?
Guys, is clear? Everything is clear? Remember, if you have some questions, you can ask directly to the teacher, okay? Turn your
Yes, teacher, is clear.
Okay, very good. It's clear, Saad. You can continue.
Okay. So now we have, let's say again, the next pair that we can have is 3 and 6. Oh, sorry, 3 and 9. 3 and 9. So let's say I have 3 times negative 9. That gives me negative 27, and its sum is negative 6. So that's what I was looking for. Okay. This is the pair. This is the pair that I was looking for. So what I do here is I break it. I break my middle number into two numbers, minus 9 and 3. Then again take the common x minus 9, plus 3 common from the next two terms, x minus 9. And then again we take out the common thing as x minus 9. We get x plus 3, So x minus 9 equals to 0, or x plus 3 equals to 0. That will give us x equals to 9 and x equals to negative 3. So we are done. All right, we got two answers, 9 and negative 3, but there is still a problem left. When we are dealing with the logarithmic equations, we can get extraneous roots, or like the solutions that are actually not the solutions. So we need to check them by plugging them in. So let's say in this case, in this question, let's say this one, x equals to negative 3. Let's say I plug it in. Okay. When x is equals to negative 3, I get log 3 to the power 3 minus 3 here. But the problem is, and this will become minus 3 minus 6 will become minus 9. All right. So the problem is we are not allowed to put the negative values in the logarithms. Logarithm function cannot take the negative values. So this one is not the root. This one is not the valid answer. This one is extraneous root. This one is not the one that we're looking for, right? So the correct answer, the one that we should be looking for is this one. Okay, again, the next one is kind of similar, so I will just leave that. Okay, so let's try the last one here. Log 5 equals to log this, right? So you see there is both of them. There's a log 5 here, log 5 here. So let's say if I take the power 5, if I write both of them in the power of 5, 5 to the power of that and 5 to the power of everything, like let's say like 5 to the power of this whole thing and 5 to the power of this whole thing, right? So this log 5 and this one, this and this will cancel out, right? So I will be just left with so again, like let's combine the like terms. So it will become x squared plus 6x minus 20. And so now again we need to factorize. We need to think of the numbers, either the oh sorry, I think this was negative. Oh. This one was negative, sorry. So then this will be negative 8. Negative 8. Okay, now I need two numbers that when I add them, I get negative 8, but when I multiply them, I get negative 20. So that will be the 10 and the 2. So I will get x squared negative 10x plus 2x minus 20. Okay, because when I add them, when I add these two, I get negative 8, but then when I multiply them, I get negative 20. So let's say I have x common, x minus 10 plus 2 common, x minus 10. Then we have again x minus 10 times x plus 2. And then from here we get x equals to 10 and x equals to negative 2. Now we need to check if these numbers work, if these are actually the solutions or they are the extraneous solutions. So let's see the 10. When I plug in the 10, when I plug in the 10 in that, I get log 5, and there's 10 times 7 is 70. So 70 minus 9 equals to log, and then 10 square is 100. 100 minus 10 minus 29. So that both of them are positive numbers. This one is a positive number, this one is positive number. So it does not, so this one is good. X equals to 10 is good. We are good with that. Now let's try x equals to minus 2, right? So when x equals to -2, I get, and 7 times -2 is -14, -9. So you see, you don't like this one is negative now here. Log of -24 or 23, which is not possible because we cannot do the logarithms of negative numbers. So this one is not the solution. Okay, this one is x equals to 10 is the answer, is the root, is the solution for this exponential or logarithmic equation, but the x equals to 2, it's not the answer, or it's not the valid answer for this one. Okay, let's now the next one is the applications. This is our next part of this thing, is the application of logarithmic functions and exponential functions. All right, so this is our application of logarithm and exponent. So okay, so this one is the application of the exponential function. All right, application of the exponential function. So many radioactive isotope substances masses decreases over time, and a useful piece of information when working with such substances in chemistry is called half-life. So there are some materials which are radioactive, and they have a life, like after some time, the half of they reduce into half. It can be many thousand years, or it can be very small time depending on the material. So we use a formula to find the half-life of the material. All right, so which is m is equals to a times 1/2 t over h. So m is the remaining mass, a is the initial mass, and t is the time it takes, and h is the half-life. H can be in years, like the time, the same unit as in the time. In like if the time is in years, then h will be in years, or if it is in hours, it can be in hours, days. Right? So the unit can vary depending on what's the unit of time we are using. So okay, so let's see an example here. Let's see an example here. Okay, Chris works in a laboratory and uses radioactive substance. She receives a shipment of 350 gram of radioactive radium. Then 2 weeks later, 23.5 gram of radium remained, right? What is the half-life of the radium? So like he got 360 grams, but after 2 weeks, he's left with 23.5 grams. He did not use it. It was radioactive. So it's just left this much now after 2 weeks, because it's the half-life, like it keep radiating and reducing. So we want to see what's the half-life. All right, so in this question, what information we have that initial amount that we get is 350. Okay? The initial amount that we started with is 350. Then the amount that is left after the 2 weeks is 23.5, and the number of days, the time that it took was 14 days. All right, so we substituted everything into the formula. So 23.5 here, 3 like m mass left after a 1/2 times t over h. Yeah, So we're plugging it into here. A initial amount is 350, 23.5 grams mass is left, then 1/2. The days are 14 and half-life h. We want to find the h. Now what we did, first of all, we divided both sides by 350. All right, and then removed the decimal, divided by 350 by reducing the decimal, right? So that's like they did it twice, like 2 times. So just multiplied with 2 on both sides, up and down, right? Multiplied this with 2 and this with 2 to make them decimal free number, but it was not necessary, but we can do it. All right, so now we have a equation which is kind of similar to the one that we was doing before. All right, now we have an equation which is kind of similar to the one that we was. So now what we should do, all right, so what they're doing is, okay, if you do the log, like log a, whatever the a here is, and then whatever the a is here, right? The answer is 1, right? So what they did is they took the log 1/2 on both sides. There is a point in taking 1/2 because when I will take 1/2, log base 1/2, log base 1/2. And then when I take the log base 1/2 and then times 1/2 to the power, then what I do get is what I do get here now is this 1/2 and this by this rule. See, this will go out, cancel out. This will cancel out. All right, and what we left with, all right, it's 14/h. And now applying the base change of base formula, change of the base formula, like if you have log ab, you can write it as log base 10b over log a. Just 1 second, all right, please, just excuse me. Okay, sorry. All right, so we have the base, like if we have the same thing, we can write them like that. So now we apply the rule of change of base on these ones. So we will write it as log 47 over 47 over 700. That's one thing, right? Over log 1/2, which is equals to h over 14 over h. All right, so then calculated this, then calculating this gives us approximately 3.90 for this one, and then and then like, so h over 14 is equals to this 3.14 over h equals to 3.90, and then we cross multiply, so h equals to 14 divided by 3.90, which is approximately also, which is like almost 3.59, or you can say that is, so like let's say 3.5 day or 3.6 days. So after 3.5 days or like 3.56 days, 59 days, the half of the amount that you put there becomes half is left and half is gone. Let's say if you put 10 grams after 3.5 days, it will be left 5 grams. Another after 3.5 days, it will be left 2.5 grams. After another 3.5 days, it will be left 1.25 grams. So after every 3.5 days, it becomes half. So that's its half life. So that's an application of the there's an application here for this one. We use the exponential equations, we use the logarithm to solve them. Okay, so now next one is like the pH. pH, like pH tells us how basic or acidic is some solution. The acidity or acidic, how acidic something is. Okay. The pH solution of a solution defined by the following formula here. It's given a formula here. pH is equals to minus log H plus, or you can write it as log 1 over H plus. All right, so that's the formula for to find the pH of any solution, is like where H plus is the concentration of hydrogen ions in the solution. So what we do here we have is if the concentration of hydrogen ions is doubled, what effect on pH? All right, like if we double the concentration of hydrogen ions, what will be the effect? So first of all, like write it like this. All right, we do it to C, right? pH is equals to minus log to C. C is the concentration of, like, pH was equals to log minus log H plus. H plus was the concentration. Now I have replaced it with the 2C, the concentration, twice the concentration. All right, so like then I break this by using the rule of the product rule of the logarithms. Break this and this, because when two things are getting multiplied and with the log, you can write them twice, or like with the plus sign in between them, separate them. And then I distributed this negative inside here. So okay, so since the pH itself, 1 pH is equals to minus log C, all right, so it will be log C minus log 2, all right. So whatever the pH was before of the object, if you increase the ions by the double, the new pH will be that pH minus 0.301. Whatever the answer you had before, it will become minus that if you increase the quantity of the hydrogen ion by twice. Okay, so this is our third topic. Next one, angles and their measure. Angles and measure. That's the next topic. All right, third one. So first of all, what is an angle? An angle is formed when two straight lines or rays meet at a common endpoint. The common point is of the contact is called the vertex of the angle. The word angle comes from the Latin word named as angulus, means corner. So that's like basically what the angle is. Okay, so angles around us, right? There are many daily life examples of an angle, such as cloth, hangers, arrowhead. Okay, they can see many things. Yeah, you see the scissor have an angle, the favorite one, the pizza, right? A good angle here. And the bigger the angle is, the more you're happy, right? Okay, so then this is again like these are the angles. Okay, the angles between your fingers, the angle between your chairs, right? Everything. So there is the angles everywhere that we can see. Even the clock that we have here, whatever time it shows, right? It's an angle. Let's say it's showing one clock, one length here and here. This is an angle here. the symbol for the angle. Okay, so this is the symbol, this symbol here, this symbol. It's not less than, all right? Don't, it's not the less than symbol. Less than symbol is something like this, all right? This one is different. It's like this. If I don't know if you can, but you have to, this is the angle, all right? Angle symbol is different than the less than, right? This is the less than symbol. So they are different. They are not same. So represents an angle. Angle are measured in degrees using protractor. For example, 45 degrees represented by like 40. Okay, so what they did before in time, like they draw the circle, they draw a circle, okay, like this. And in the past times, they were used to count the thing, like the base unit was not, they were not counting the things by the 10. They were used to count it by the 60. Like that's why you see there is 60 seconds in a minute, there is 60 minutes in an hour, right? So like that. So they measure the things by like the by the unit of 60. So what they did is they took a circle, right? And they do and then they like draw the lines. 360 lines are equal. They did the 360 equal parts of the circle, right? They did the 360 equal parts of the circle. We did 360 equal part of the circle, and then the one part, like how open it was, one part, they call that 1 degree, right? 1 degree is in reference with the 360 degrees. Like in a circle there is 360 degrees, there is 360 equal parts that we divide the circle in, and then the angle that is of the one part is 1 degree, right? So let's say like this one is 45 degrees. It means this one covers 45. Like if there is 360 parts of the circle, this one covers, this one is the 45 parts of that thing. Okay, so next there is some parts of an angle. Vertex. A vertex is a corner of an angle, a point where the two lines meet. O is the vertex. So like this is the vertex here where the two lines meet. Where the two lines meet, that is called the vertex. This one is an arm, this one is an arm. Okay. Two sides of the angle joined at a common endpoint. OA and OB are the arms of the angle. So this one, OA is the arm, OB is an arm here. So initial side, also known as the reference line, right? A straight line from where the angle is drawn. OB is the reference. Like you have to like draw one line first, then obviously you will draw the second line. So the line from where you started, and then you measure it from where, then you open your protector or compass like that, and then you draw the second line. So this arm is the initial arm, initial side, and the one over which it ends, it called terminal side. Terminal side, okay, the side up which the measurement is done, right? When the measurement is done, the side that is up there, that is called the terminal side. Okay, so there is some types of angles based on their measurements. Here are the types of some angles. The acute angle, measure less than 90 degrees at the vertex. The angles that are less than 90 degree at the vertex are called acute angle. Okay, acute angle. That's acute angle. Okay. Then an obtuse angle, an obtuse angle is between 90 degrees and 180 degrees. So if it is in between 90 to 180, then we call it obtuse angle. All right. Okay, a right angle. Right angle, next one is. If the angle is precisely measured 90 degree at the vertex, 90 degree at the vertex, 90 degree at the vertex, then it's a right angle. If it's 90 degree at the vertex, then it's the right angle, right? An angle measuring exactly 180 degrees. If it's exactly 180 degrees, then we call that a straight angle. Straight angle. 180 degree means when you will draw 180 degrees, it's like, you think you had a circle and the circle had 360 degrees in it total. So 180 degrees means you will half it up, right? You will half up the circle, half of the circle. So when we do the half, the thing that we get here in the middle is it's a straight line. You do not have any bend. The angle 180 degree angle is a straight line. It do not have any bend. So that's why it's called straight angle, because it's a line. It do not have any bend in it, do not have any corner. 180 degrees angle do not have any corner. So that's why it's a straight angle. Okay, the next one is the next one is the reflexive. Okay, reflex angle. Okay, so if the angle is in between 180 to 360 degrees, we call that the reflex angle, right? 180 to 360 is called reflex angle, right? And a complete angle measure equals to 360 degrees. Here are some examples. Oh, okay, I think. Okay, so you see this is acute angle, right angle, obtuse angle, straight angle. This one is not correct, the reflex angle. They have written like I have written 240, but it's actually, sorry, this was not supposed to be here. It was like the 240 is this one, the other one that's not there. This angle, this much angle. The bigger angle was 240, not this one. Sorry. It's the red one, red angle. That is 240, the bigger side. Okay, and this is 360. 360 means a complete circle, like from where you started, you ended there. Okay, then there is complementary and supplementary angles. Complementary angles are if the angles add up to 90 degrees are called complementary angles. Here, okay, so this angle BXC, BXC and CXD, these are complementary angles because they sum up to 90 degrees. They sum up to 90 degrees, so they are complementary angles. And the supplementary angles are the one that sum up to 180 degrees. This angle that sum up to 180 degrees are the supplementary angles. All right. So like AXT, AXD, this one, and CXD, this one. These two sum up to 180. So they are supplementary angles. Okay. Here we have a question. Find the missing angle X. We need to find this angle. Can anyone help me with this? Would you like to help me to find this missing angle?
Guys, is clear or
No, it's okay. I just want like them to
question?
participate. Do they want to participate? Okay, it's 55. All right. Okay, let's see. Okay. Okay, let's see. So This one is 180, all right? This much is 180. So the other remaining half is also 180. The remaining half is also 180, all right? And even that we can see this much is 90. This much is 90. There is a straight angle, 90. So out of 90, there is 35 already. Okay, there is 35 already. All right. So these two, x and 35, are complementary pair of angles. So they should be equals to 90. So x should be 90 minus 35 because they are complementary angles. They sum up to 90. So that should be, we get that as 55. So that was the correct answer. X equals to 55 is this angle is 55 degrees. Okay, so now this is the last one, trigonometric function of an angle. This is the last topic for now, like this is the fourth topic for the day, the last one, trigonometric function of an angle. So there are 6 functions of an angle commonly used in trigonometry. They are named in abbreviations are like sine, and it's not sin, it's read as sine, okay? And this is cosine, it's read as cos. Tangent is tan, and cotangent is cot. Secant is sec, like you read it, but it's secant. And cosecant is represented as csc. Okay, so the 6 trigonometric ratios, 6 are in relation with the right triangle. Let's say we have a right triangle, all right, are displayed. And okay, so the triangle contain angle A and the ratio of the side opposite, like let's say this is angle A. So the ratio of the side opposite to A to the and the right angle. Okay, maybe I should move. I have, okay, like here. You see the sine. The sine angle is the one. Sine of A is the one. This is, let's say, the angle A here. The opposite over hypotenuse. Let's say we had a triangle. We took the opposite and we divide the opposite and the hypotenuse. So that is the sine. That ratio gives us the sine. Then we divide. Then if we do it like we take the B, the adjacent side, and divide it by the B and divide it by the C. Okay, adjacent side divided by the hypotenuse, that gives us the cos ratio. Okay? That is the cos ratio is of the side, like adjacent side divided by the hypotenuse. Then the next one is the tangent. Tan is like dividing the opposite by the, we can do that, like I'm just looking at all the options, right? I took the A, I divided it by C. I took the B, I divided it by C. Now I took the A and now I'm dividing it by B. All right, so opposite side divided by the adjacent side. This ratio we named it as tangent. Now these ones are the opposite. Let's say, so sine and the cosecant, sine and the cosecant. So sine of angle A is equals to 1 over CS, cosecant of angle A. They are the reciprocal. What we did, I flipped them. I divided, now the C is on the top, A is at the bottom. Okay, so now I'm dividing this one by this, right? Similarly, cos A is B over C. Now if I do C over B, hypotenuse over the adjacent side, then it will be secant. So cos of A is equals to 1 over, and similarly tan of A is equals to 1 over cot of A. Okay, so they are the reciprocals of each other. So these are the basic 6 angles that we can have with the triangle or with the like for an angle. All right. See, these are the 6 ratios, 6 trigonometric ratios that we can find for the angle. So let's say if let's say if I then I have to like find, like if we are given in the numbers, let's say this is 30 degrees or let's say this is 45 degrees, all right? So let's say, and this, then we should have sides, like any of the sides. So or we can, let's say this one is 4, let's say this one is 4, this one is 5, and this one is 3. Okay, so sine of this triangle A, sine of angle A for this one is 4/5. Cos angle of this one for A is 3/5. The tan angle for this one, tan angle A is 4/3. So similarly like that. All right. All right. So that's it. So these are the basic 6 angles, like 6 trigonometric functions that you can find for an angle. If you're given an angle, you can find its sine, you can find its cosine, you can find its tangent of that angle, you can find the cotangent of that angle, cosecant of that angle, and secant of that angle. Is it okay? Does anyone have any questions?
No, teacher. Is everything clear?
All right.
Okay, guys, it's clear everything, right?
Yes, teacher.
Okay.
All right. Okay, then have a good day.
Okay, excellent class, Sa. Thank you. Have a wonderful day for you. Thank you guys for being here. Enjoy the rest of the day. Be pending for next class. I want to see you next class, okay? Have a wonderful day. Bye-bye.
Bye, teacher.
Bye, guys. Ferdi, Joseph, Facundo, Santa,
Bye, miss.
Ferdi. Thank you.